Good afternoon to everyone. All of you can able to hear my voice? Hello, good afternoon.
Good afternoon,
Good
sir.
afternoon, sir.
Are you able to hear my voice?
Yes, sir.
Yes, sir.
Hello. Are you able to hear my voice?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Okay. Today, what I'm going to do, I'm going to designing a 2-bit, the last class continuation. Okay. That is nothing but we are going to designing a synchronous circuit, a synchronous up counter using JK flip flop. Okay, anyone tell them what is the procedure when you are going to designing a synchronous counter? What is the first step? Anyone tell them? You should find out number of flip flop in order to design given equation. Okay, for example, given equation is you want to design 2-bit synchronous counter. So how many number of flip flops are required? 2. So how many number of states are available? 4. So what is the step 2? Step 2 is simple. You want to draw the state diagram. This is a state diagram. Okay, how many number of states are available? Okay, 0, 0, 0, 1, 1, 0, 1, 1. This is up counter. So what happened? This is initially 0, 0. Now what happened? 0, 1, and then after that what happened? 1, 0. After that what happened? 1, 1. Okay, this is an increment counter. So such a way that the diagram should be okay. So what is the next step? Okay, you should write excitation table of JK flip flop. So already we have discussed in the fourth unit how to draw the excitation table. Okay, suppose you are unable to understand it, go and refer those notes. Okay, so what are the parameters are available in the excitation table? So this is called as a present state. This is what is the respective input combination. Suppose if input is 0 0 in the sense, so what is it? Sorry, my present state is 0, next state is 0. So what is the respective input in the sense? 0 don't care. Next condition is 0 1 in the sense 1 don't care. 1 0 in the sense don't care 1. Okay, should uh, please go to the fourth unit. In the whenever we talk about JK flip flop, we have discussed about what is the excitation table of JK flip flop. Go and refer those notes. Okay, how to derive it. Okay, and then 1 1. So 1 1 in the sense. Okay, this is the input value. Okay, what is the next step? Okay, you should write. Okay, you should form minimize the Boolean expression from excitation table. Form minimize Boolean expression from. Okay. So how do you do that? Okay. So here two flip flops are available. So each one of them had a present state. Similarly, each one of them had the next state. Okay. And then if it is there, what is the required input? If it is there, what is the required input? So so always the element is represented from, for example, how the flip-flops are connected in the sense such a way that it should be appear. Okay, already I said this is treated as a LSB, this is treated as a MSB. So whenever you are going to write the element, in the human readable format. How we are going to write that? We start from MSB to LSB. Okay, so such a way that we are going to write that. Okay, such a way that what happen? I am going to write the output. This is a MSB, and then followed by LSB. Okay. Okay. Suppose this is a uh, two variable function. How many number of input combinations are available? So, okay, 4. So before that, what happen? I'm going to write the state. So Q1, okay, you should write the input from MSB to LSB. Q0. So, okay, what is the meaning is, for example, this is a flip-flop. Okay, for example, JK, this is the first flip-flop. Okay, this is the second flip-flop. So this is called as a Q0. This is called as a Q0. This is called as a Q1. This is called as a Q1. Sorry, Q1. This is called as a Q1 bar. Okay, I already said this is called as a LSB, and this one is called as a MSB. Okay, what happened? We are going to represent it. What is the previous state? So, okay, so here two flip-flops are available. So each one had the previous state. Q0 is nothing but the previous state of first flip-flop. Q1 is nothing but previous state of the next flip-flop. Next flip-flop. Okay, okay, same for. So what about next state? So Q1, Q0. Okay. So for example, how I am going to take the previous state in the sense, you will take the previous state based on the state diagram. For example, what is the initial state? 0. What is the next state? 0, 1. Okay. Similarly. So the next state, what happened? It is acting as previous state for next clock cycle. That's why I'm going to write it here. Okay. So what about next state? 1, 0. Okay. So what happened? The next state, it's acting as previous input for previous state for next clock cycle. So 1, 0. So what about next state? 1, 1. Okay. Okay. So how do you fill up that input value? Okay. How do you do that? Okay. Listen. Suppose my input is 0. Okay. My present state is a 0. My next state is a 0. In the sense. So what is the input combination of G and K? What is the input combination? So Q1 is 0, present state is a 0, next state also 0. What is the input combination? Anyone tell that? Anyone tell that? What is the input combination? In the table apart. So 0, this is a present state, this is a next state. So what is the input combination?
0 don't care.
0 don't care, that's all. Similarly, for example, next what happened? Next clock cycle, the Q1 state is 0, the next state is a 1. Okay, next state is 1. Okay, look, how do you fill up the table? Go to the truth table of JK excitation table. Previous state is a 1, the next state is, sorry, previous state is a 0. So what is the input combination? 1x, 1x. Similarly, 1, 1. So 1, 1 in the sense x 0. This is a two variable function, so 4 input combinations are available. 1, 1. Next it will reach same state. Okay. The present state is 1. The next state is 0. The present state is 1. The next state is 0. So what is the input combination? X1. Same procedure you are going to apply for Q0. Okay. Anyone tell that? What is the answer? Anyone tell that? The Q0 present state is 0, the next state is a 1. So what is the input combination? Are you able to understand?
1 don't care.
Okay, 1 don't care. So what about next?
Don't care 1.
Don't care 1. So what about next?
1 don't care.
Okay, 1, 0. Sorry, 0, 1. 0, 1. What happened? 1 don't care. Okay, next. Okay, 1, 0. Look at the table. 1, 0. What happened?
Don't care 1.
Don't care 1. That's all. Okay, now what happened? We form the excitation table of the given two flip-flops. Okay. So in this one, So this is acting as an input, and then the required input is acting as the output. Okay. So how do you form the Boolean expression? So in order to form the Boolean expression, what you are going to do? Number one, I'm already discussed on it. So what we have did is. So what are the outputs are available? Anyone tell that what are the different type of outputs are available? So what are the different type of outputs? J1 one output, K1 is one another output, J0, K0. Am I correct?
Yes, sir.
So each one of them you want to form a Boolean expression. How do you do that? First you take J1. Okay, this is a two variable function. Okay, so in order to form the Boolean expression, what happens? I will use two variable columns 0 1 0 1. Okay, what are the two inputs are available? Okay, the first input is called then followed by Q naught. Okay, so what are the places of output value equal to 1? Here 1. So what is the input combination? 0 1. Okay, 0 1. Here the value equal to 1. So what about next case? So here don't care condition is there. Here also don't care condition. So whenever you are going to form K map, okay, you should in the K map itself you want to represent the don't care condition also. Okay, so what is the input combination? 1 0. So don't care. So what about here? 1 1. Okay. So next, what is the next procedure? You want to form a grouping. Okay. So if you do that, what is the answer? Anyone tell that? What is the answer? What is the answer? This is a fixed one. This is a keep on varying. If you look at the diagram, you can easily tell that. What is the answer? Q naught.
Q naught.
Q naught.
What about K1? Same procedure you are applying for K1. Okay. This is a two variable function. Okay. You apply Q1. This is a Q naught. 0 1 0 1. Okay. What happened? Okay. So what are the places of tal equal to 1? Only here only. So and then two load conditions available. So you should represent in the K map itself. So 0 0 position load condition is there. And 0 1 condition load condition is there. Okay, you want to represent it in the K. Okay. If you minimize, what is the answer for K1? Anyone tell that? What is the answer?
Q naught.
Okay. Okay. So similarly, what is the next output? The next output. The next output. Okay, try to use it. What is the next output? Here I am going to write that output J1 equal to Q naught and then K1 equal to Q naught. So what about next combination? So what about next combination? Okay, form a Boolean expression for J naught and K naught. Okay, anyone tell them what is the answer? Anyone tell them what is the answer? 0 1 0 1. Which is called as Q1. This is called as Q1. Okay. So what are the places output value equal to 1? So 0 0. And then what is the next one? 1 0. So what are the places of the don't care conditions are available? Here and here. Okay. Okay. So what type of grouping possible here? What type of grouping possible here? What type of not bad because so sir whenever you are going to perform grouping operation, okay, you should focusing on maximize grouping. So here what happened? Pair also possible, but I can able to form quad grouping. If you do that, what is the answer? If you do that, what is the answer? Say everything is keep on changing. Q1, Q0. This is 0, this is a 1. This is 0, this is a 1. Keep on changing. What happened? So only 1. This is cancelled, this is cancelled. What happened? So only 1 is there. So what is the output of J naught? Is the output of J naught?
1.
1. அதாவது grouping நீ பண்ற அப்படின்னா இப்போ don't care conditionலாம் இருக்கு. எனக்கு don't care condition வச்சு I can able to form biggest group in the sense you can proceed that grouping. புரியுதா? Pairing also possible, but நம்ம grouping பண்றப்ப என்ன பண்ணணும்? We should focusing on So biggest group. Then only what happen? We can get minimized expression. சொல்றது புரியுதா?
Yes, sir.
Okay, what about T naught? Okay, should apply same procedure. Anyone tell that what is the answer? If you look at that value, okay, you can easily tell the answer. So 1 1, the rest of the position what happened? Don't care condition is available. Am I correct?
1, sir.
Answer is 1. Okay, 1. Don't care condition. What happened? The answer is k equal to 1. Okay, now successfully we formed. Okay, we now successfully formed. So minimize the Boolean expression. Now we have successfully formed minimize the Boolean expression. The k1 value equal to q0 and sorry j1 value equal to q0 and k1 value equal to q0 and j0 value equal to 1 and k0 value equal to 1. So based on that, what happen? You should write the logical diagram. So how do you do that? So here 2 bits are available. So in order to designing the counter, you needed a 2 counter. So whenever you are going to designing any synchronous counter, you can use any one of the flip-flop. So what are the different types of flip-flops are available? So J, K, data flip-flop, T flip-flop. Okay, you can use any one of the flip-flop. Okay. Suppose you are going to designing for 4 bit or 8 bit. Whenever you are going to designing, uh, suppose the higher end, okay, most probably you go for doubling flip-flop or T flip. Okay, you don't that case you don't go for JK flip-flop. If you go in the sense what happens, your circuit should be again very bulky. Okay. So here the question itself they given, you want to implement 2 bit synchronous up counter using JK. Okay, so that's why I'm going to take the 2 flip-flop. So each one of them is going to produce an output. This is a Q1, this is a Q1 bar. Output. Okay. And this is called as a synchronous. What is the meaning of synchronous? So each flip-flop what happened? We are going to apply same clock cycle. That's why it's called as a synchronous. Okay, you can apply any either positive edge trigger or negative edge trigger. Both of them it produce the same output. Okay, so okay, so what is the input for J1? So input for J1 is nothing but Q0. So I'm directly connected like that. So what about K1? So this is called as a K1. So what is the input for K1? The input for K1 is nothing but Q0. So what about next one? J0. What is the input for J0? 1. What about input for K0? 1. So this is a circuit diagram for 2 bit synchronous up counter. Okay, do you have any queries? Do you have any queries?
No, sir.
Okay. So I will provide one example problem. You can try it out yourself. Okay. Well, let's try. Okay. 2 bit. Okay. 2 bit synchronous counter. Design 2 bit synchronous counter. Synchronous counter. Synchronous up counter. Synchronous up counter. Using double flip-flop. It is called as a T flip-flop. Okay, you tried out yourself. Okay, uh, this is a homework problem. Okay, okay, you will try it out yourself in your home. Okay. So next, I go for 2 bit, 2 bit synchronous down counter. Okay. So what is the first step? How many number of flip-flops are required?
2, sir.
2. Okay. So what is the next step? How many number of states are available? 4. Okay. So what are the dot states? 0, 0, 0, 1, and then 1, 0. This is nothing but 1. So what is the binary decimal representation? 0, 1, 2, and then 3. What is the next step? You want to draw the state diagram. Okay. So this is a down counter. Okay. How the state diagram should be appear? Okay, the initial state is 0, down counter. Okay, initially 0. What is the main functionality of down counter? It's keep on decrement the value. That is a functionality of down counter. Okay, initially 0. What is the biggest value in the? So you had a 4 state. So among the 4 state, which one is the biggest value? So this is the double one is nothing but this is a 3. Biggest value. First 3 is there, and then followed by 2 is there, then followed by 1 is there, and then again it will reach starting state. So this is called as a down counter. Okay, this is called as a down counter. Okay, it's okay for you? It's okay for you?
Yes, sir.
Okay. So what is the next step? You should write write excitation table now. Here, what is the flip flop? So you want to design the down counter using double flip flop. Okay. You want to design the not T, JK. Okay. So already I said, whenever you are going to designing any synchronous counter, you can take any one of the flip flops, either JK, data flip flop or toggle flip flop. Okay. So both of them is going to produce the same result. Okay. So here what happened? I'm going to take JK. So what is the excitation table of JK? Anyone tell that? The excitation table of JK. The excitation table. One don't care condition 1, and then don't care condition is 0. Okay, what is the next step? You want to form minimized Boolean expression from the excitation table. Okay, that is the step 4. Okay, so the excitation in the sense you had a 2 parameter. One is called as the previous state, next one is called as the next state. So here 2 flip flop. Okay, so how it's a connected? First Q1 J0 is there, and then followed by J1 is there. So this is treated as LSB. Okay, this is treated as MSB. Okay, so whenever you are going to write the output, okay, this is called as a Q0, this is called as a Q1. So how we are going to write the output? First the MSB and then followed by LSB. So that's why I'm going to write it here. So Q1 and Q0. Okay. Similarly, Q1 and Q0. Okay. So what is the required excitation? Required input for flip flop. Okay, suppose I'm providing the clock 1. Okay, sir, how am I going to fill up that value? What is the value of Q1 and Q0? Okay, first you look at that state diagram. What is the first value? 0. What is the next value? 1, 1. In the next clock cycle, this is acting as a previous present state. Okay, what is the next state? 1, 0. So next clock cycle 1, 0 is acting as a present state. What is the next state? 1, 0. Sorry, 0, 1. Okay, next clock cycle what happened? 0, 1. This is called as a, what is the next step? 0, 0. So this has happened first, this has happened second, this has happened in third, this has happened in fourth. Okay. So what is you should find out what is the record in. Okay, so this is a JK. Okay, first I write MSB and then followed by LSB, J0 and K. So anyone tell that what is the answer for this one? What is the answer? The initial state of Q1 is 0. The next state is 1. What is the output? What is the output?
1x.
1x. What about similarly for next? Previous state is 1. The next state is 1.
x0.
x0. 1, 0. Is the 1, 0. x1. What about next one? 0, 0. 0x. Okay, same procedure for Q naught. Okay, if you do that, what is the answer in the sense 1x, x1, sorry, don't care 1, and 1 don't care, and don't care 1. Okay, what is the next step? So in this diagram, which are the parameters acting as an input and which are the parameters acting as output? So present state is acting as an input, and then the required input is acting as output. Okay. So you will try it out yourself and find out the answer for. If try it out yourself and find out the answer for. Find out the answer for J1, and first you should find out J0 and K0, and then followed with J1. Okay. Try it out yourself. What is the answer for J0? Anyone tell them? Anyone tell that? What is the answer? If you look at that, you can easily tell that. So 1 1, the remaining cases what happen? Don't care condition is there. If it is there, what is the
1, sir.
1 out
1,
of
sir.
What about K naught?
1.
1 on that one. Next. And then go for J1. Okay, here one place is 0. So because of that, you should draw two variable kernel. Okay, what's the value? Here you will get two possibilities. One is nothing but Q1 bar, another one is nothing but Q0 bar. Okay, you can take any one of the value. So in my cases, what happen? I'm going to consider Q0 bar. Similarly for K1. So K1 value is nothing but you will get the two output. So anybody got two output? Okay, you will try it out yourself. So such a way that it appearing. So here what happened? 1 x x. Okay, if it is there, what happened? Okay, this is one type of grouping is possible. You can do that another grouping. So because of that, what happened? You will get the two output. Okay, you can while writing the output, you consider any one of the output. Okay, so K1 equal to Q0. Okay, so now we successfully found the Boolean expression. Minimize the Boolean expression. So what is the next step? Auto designing it. Okay, so this is the first flip flop. This is the second one. Okay, the first input J naught and K naught. So what is the output? First output Q naught bar. Okay. What about next one? J1, K1, Q1, Q1 bar. Okay. So what is the input for J naught, K naught? 1, 1, 1. So what about J1? J1 is an input Q naught bar. What about K1 bar? K1 bar is an input Q naught bar. Okay. So in order to operate all the flip flops are accurate clock. Okay, this is a circuit diagram for 2-bit down counter using JK flip flop. So do you have any queries?
No, sir.
So next what happened? I'm going to listen 3-bit synchronous counter. You can try it out yourself. Okay, try it out. I will call random any one of them. Okay, you want to tell the answer. Okay, you want to designing 3-bit synchronous up counter using T flip flop. Using T flip flop. What is the first step? What is the how many number of flip flops are required? 3. Okay. How many number of states are available? 2 power 3 is nothing but 8. So 8 states are available. Okay. So what is the next step? You want to draw state diagram. Okay. This is up counter. So what are the possible states are available? So 0 0, 0 0 1, 0 1 0, and then 0 1 1. Okay. Next 1 double 0, and then 1 0 1, 1 1 0. Next one 2 1. Okay, this is up counter. So what happens? Keep on incrementing the value. Okay. So here to there, it's a flow from here to there, here to there, to there, here to there, here to there. This is condenser counter. This is condenser state diagram. So do you have any queries?
Oh, sir.
Okay. What is the next step? Excitation table of T flip flop. So sorry, excitation table of T flip flop. This is the truth table for excitation truth table for T flip flop. So 0, 0, 1 in the sense 1, 1, 0 in the sense 1, 1, 1 in the sense 0. Okay. Okay, this is a truth table. Okay. What is the next one? Okay. The next step is you want to form minimize the Boolean expression from the given excitation table. Okay, how do you do that? Okay, you are going to fill up the table. Okay. So what are the parameters are available? Anyone tell them? So present state, the next state, and then record input. Okay, this is a class. Okay. So what are the states are available? So this is a three variable. This is nothing but 3-bit synchronous counter. How many number of states are available? 8. So that can be denoted as U2, U1, and Q0. Okay, how do you write the state? Okay, based on the state diagram. Initial state is a 0, 0. Next one is a 0, 1. Next one is 1, 0. And the last one is 1. Next 1, 0, 0, 1, 0, 1, and 1, 1, 0. The next one is 1, 1. Okay. What about next state? This is acting as a next state. 0, 0, 1, 0, 1, 0, 0, double 1, 1, double 0, 1, 0, 1, 1, 0. Okay, 1, 1, double 1. Next one is another 0, 0. This, do you have any queries? This step, do you have any queries? Do you have any queries?
No, sir.
Okay. So, okay, so what are the outputs are available? Each T flip flop, what happens is going to generate. Uh, so each T flip flop, what happens? It's going to accept single input alone. So how many number of input variables are available? T2, 3 flip flops are available. So each one of them, what happens? It's going to single input. Okay. Similarly, okay, you apply the excitation table. My percentage is 0. My next state is 0. So if it is there, what is the input combination?
0, sir.
0. You apply same procedure you apply for the rest of the input combination. Okay, you will write out to yourself. Then you are going to tell the answer. 0, 1, 1, 0, 0, 1, 1, 1, 1, 0, 0, 1, 0, double 1, 0, 0, 1. Last case is 1. All of you got this answer like that? Okay, you tried out yourself. Okay, definitely you will get same answer. Okay, so okay, now you successfully form uh, truth table. Okay, minimize the excitation table of that required problem. So what is the next thing? You want to form the Boolean expression. How do you do that? So in the excitation table, so which one is acting as the input? The present state is acting as the input. The input is acting as output. Okay. The input is acting as output. So three outputs are available. T2. Okay. First you take T2. So this is a 3-variable column. So definitely it's because 3 variables are available. So that's why I go for 3-variable column. So 8 input combinations are available. 0, 1, 0, double 0, 0, 1, 1, 1, other 0. What are the input parameters? Q2, Q1, Q1. Okay. So you look it into the 32. So what are the places output value equal to 1? Okay. So 0, double 1. here. So what about next one? 1 triple. So what is the output? Anyone tell that? What is the value of T2? Is the value of
Q1
T2?
Q0.
Q1 Q0. Okay. Same for T1. Okay, what is the answer? What is the answer? Anyone tell that? 0 1 0 0 0 1 1 1 0. This is Q2. This is Q1 Q0. Okay. Okay. If you look at the table. So what are the places output equal to 1? 1, 2, 3, 4. 4 places. Okay. If you put the values in this kernel map, the kernel map should be look like that. If you minimized that expression, so what happened in the sense? The T1 value equal to Q0. You tried out yourself, definitely you will get same answer. So what about last case? T3. So what about last case? T3. Here what happened? All the input, all the value, all the base output values are 1. So if it is there, what is the output? All the cells, the values are 1. What happened? So what happens, sir? All the cells values are 1. What happened?
1, sir.
1. Okay. The T3 value is nothing but 1. Okay. So now you got the record minimized Boolean expression. So based on that, okay, should draw the logic diagram. Okay. Okay, now these are the minimized Boolean minimized expression. So this is a 3-bit. So definitely it's require 3 consecutive T flip-flop. Okay. So what is the input? T0, T1. This is a T2. Okay, this is treated as LSB. Okay, this is a sorry. Yes, correct. This is treated as LSB. Okay. So what is the input? So it's going to produce the output as a Q0. It is going to produce the output as a Q1. This is output produced as a Q2. Okay, this is called as a Q0 bar. This is called as a Q1 bar. This is called as a Q2 bar. Okay. So what is the input for T0? 1. So what about T1? Okay. So in order to operate all flip-flop, it's required clock pulse. Okay, you can apply any one of the clock pulse, either positive or negative. So both of them get produce the same effect. Okay. Okay. What is the input for T1? Okay, Q0. Okay. What about T2? Okay. What about T2? So T2 is nothing but the combination of, okay. So because of it, I'm going to take on AND gate. What is the input for input of AND gate is one of the input is Q1, another input is Q1. The output of AND gate is input for T2. Okay. So this is a circuit diagram for 3-bit synchronous up counter. Okay. Do you have any queries?
No, sir.
Okay. So I will provide one more homework problem. You will try it out yourself. Okay. So next problem is, okay, you will try it out yourself. Next one is 3-bit synchronous. 3-bit synchronous down counter. Okay. And then implement using D flip flop, data flip flop. Okay, you will try it out yourself. Okay. Definitely tomorrow I will call randomly any one of them. Okay, they want to answer. Okay. So what about time now? 5 more minutes are available. So remaining thing we will see the next class. Okay. So now I'm going to take the attendance. So anybody had any queries regarding this?
No, sir.
Okay. So if you had any queries to be stay on online, otherwise you can wind up the session. Thank you.